without further ado, I'm going to give it up to Justin Castilla. He is a senior developer advocate for Redis. He creates educational content in the form of online courses, live streams, scripted videos, and conference talks. This is his first conference submission. He has worked as a full stack software engineer and a coding bootcamp instructor, and in his spare time, he enjoys building synthesizers, guitar pedals, and other various electronic gadgets by hand. Without further ado, what's that smell? Detecting air quality with Python, Raspberry Pi, and Redis.
I am very honored to be the last speaker. Sadly, this is going to be a bit of a bummer talk. So hopefully we'll find some joy and happiness in this talk. But yeah, so hi, Justin Castilla, Senior Developer Advocate at Redis, which is a NoSQL database. Shout out to Ria Bhatia, who was speaking on SQLite yesterday. Almost made me rethink my career path with NoSQL. Also shout out to Colin Dietrich. You'll see in this talk how his efforts and people that also work on sensor drivers allow people like me to stand on their shoulders and make cool stuff. So, okay. Bummer introductory stats for the 2020 wildfires in the United States West Coast. This can also include the Canadian coast and anywhere where there's wildfires. First, does anybody live in the West Coast and has experienced bad air quality from the wildfires? Yeah. Yeah. Big bummer. Not fun. Some sad stats. 10.27 million acres of land burned. I was living in California in 2020, so that includes for me Paradise, California, which was completely razed to the ground, and a large amount of Santa Rosa, where a lot of my friends lived, and housing developments were just completely razed. 58,258 individual fires, and that's caused by natural causes, so dry lightning strikes, those are horrifying. Horribly maintained electrical grids, PG&E for California, tons of different reasons, just bad actors too. 176 acres average per fire, 13,887 buildings destroyed, so houses, farms, commercial buildings, you just name it. $20 billion lost financially, and that's just the initial cost. There's an intangible cost of rehousing people, rebuilding industries, rebuilding entire cities, who knows. And 1,200 to 3,000 excess deaths from exposure to wildfire smoke. I was not present in wildfire. I was backpacking once in Lassen Volcanic National Park, and we woke up and it was like orange outside, and like we have to run. So I ran, if you can believe it, 5 miles in the mountains to our car. But it affects a lot of people. Also, we learned about fire tornadoes. Didn't know that was a thing. This bad boy clocks in at 400 miles per hour. That sucks, you know? It's just, damn, nature. So how does it affect wildfire smoke? So I'm not going to talk about the gigantic fires, but like if you are in a city and it's just nasty out and it smells like a campfire for like 3 weeks straight, what's going on? What can it cause? Eye and respiratory tract irritation, reduced lung capacity and function because it's being full of gunk and bad stuff, bronchitis, exacerbation of asthma, and heart failure because your heart's working harder to work with this crap air that it has to deal with, and premature death. For me personally, it felt like I used to be a smoker. It felt like I smoked a pack of American Spirits in like 4 hours. I sounded like Sam Elliott. It was horrible. Then I started getting headaches, and a lot of friends just couldn't go outside and had to like seal up their houses with tape and just run the air purifier all the time. So what was causing that? In particular, PM 2.5, or particulate matter, there are 2.5 micrometers and smaller. That size means that it can actually get into the smaller air sacs within your lungs, and it can actually pass into the blood from the air-blood exchange barrier. That's actually the scarier size. And AQI, we probably have all gone to a website to check the AQI. It's like, ooh, it's orange outside. Ooh, it smells like a campfire. Ooh, I can't breathe. What's going on? The AQI, it's an index based off of the PM 2.5 value. And you have to run it through an algorithm based off of the density of the particulates, and it gives you a value. Generally, we think of 0 to 100 as breathable. Above that, it's getting a little scary. Here's also a table that a lot of us have probably come to somewhat memorize. Where I was living in Oakland, a lot of times we had the purple and the actual maroon, and that was a very, very scary time. Also, I don't know if anybody ever remembers this, my cover photo, that was the red day of the Bay Area. That was September 9th, 2020. I woke up at 8:30. I like to sleep in. And I looked outside, and it was red. This is my camera compensating for the light. They're like, no, it's not red. It's just the sunset. No, it was red. All day, it was red. All the lights were on, birds were quiet, cats were freaking out. It was very, very scary. So TLDR, I'm measuring this air quality hyperlocally, and I'm setting up things to protect myself from bad air. So I'm using an easily available particulate matter sensor, the PMS 5003. They're $13. You can get them on Amazon, eBay. Yeah, they're very small. These little red devices, they have an actual PMS 5003 and a Raspberry Pico unit, which is smaller than a Raspberry Pi, considerably smaller, and we'll go into that. I don't know if you can see that. You probably can't because it's so small, but. So how does this work? Lasers. It's kind of cool. There's a tiny little fan. The world's tiniest fan exists in this thing, and it breathes in air, and this air goes across a laser. The laser is scattered from the particulates within the air, and it's able to actually count the particulates, the amount of particulates in the air as it goes through. And from there, it actually gives me information that I can use. So I'm attaching it to a Raspberry Pi Pico. It's pretty impressive statistic for a little tiny, like it's about the size of a stick of gum. 2 megabytes of onboard flash memory, 264K of RAM, dual-core ARM processor, and it has wireless, which was really great. Wireless makes it mobile, and the possibilities are endless. And it's $6. That's really great. You can go to Adafruit, SparkFun. It's a little bit more expensive on Amazon, but if you go into the hobbyist electronics sites, Pimaroni as well, for the UK, you can get some really great costs. I want you all to build these, by the way. And I'm sending all this data to Redis. So let me wear my Redis hat. It is a NoSQL database, so I store data structures in there, and I can store time series and JSON and streams, just strings and numbers too. So everything but a SQL row and table. And it runs on RAM, not on a hard drive. So no spinny disks, it runs in sticks. So it's inherently very, very fast, very, very fast. So here's this code. This is MicroPython. MicroPython is just basically a simplified version of Python that you can upload into a PicoW. You can also use CircuitPython, but I really took a liking to MicroPython. And you have to tell it everything: how to connect to the wireless, what to do if you cannot connect to your wireless access point, things like that. And here I am, for the most part, just connecting to the wireless, and at the bottom, I'm connecting to a Redis client. Thankfully, somebody had a lot of time and a lot of passion, and they created a client for Redis for MicroPython. The cool thing about MicroPython, well, or the challenge, there's no pip really for it. So you just find your package, you find your files, and you plop them down there right next to your main file, and you just reference it by importing, which is nice. Very simple. So here I am connecting to the wireless, then connecting to Redis, and then you do everything within a PicoW in a while loop, because you want it to continuously run. So I'm doing a couple things. First, I'm screaming into the void towards Redis, saying, I am a sensor, and I am alive. So this sensor right here, I don't know if you can see that, is a sensor 1, or unit 1. And these are all different sensors. So you have 1, 2, 3, and 4. This is announcing to Redis that it's creating a string. It's saying it's active. And I'm setting, you'll see here, a TTL timer. Expires TTL, so I expire in 5 minutes. That's basically saying if this doesn't report back in 5 minutes, that means that we've considered this sensor lost for whatever reason. No signal, somebody stepped on it, what have you. Bad connection. And after 5 minutes, it announces itself again to Redis, just so I know what's available to look at. And this try clause over here, I'm actually reading the sensor. It's that simple as sensor.read. Another shout out to people who write drivers to our hardware, to our sensors. This made my life so much easier. And Pymaroni, which is the UK retailer for a lot of Raspberry Pi and hobbyist electronics, one of the employees there actually wrote this driver. So I'm like, thank you. This driver is also available for Python, normal Python too, and as well for the Raspberry Pi. So I'm taking a raw reading, and that's going to give me the particulate density. That's just how many little bits of solid matter it found within a cubic meter. So not within like a cubic millimeter, within a cubic meter. So that's kind of interesting. And this it will give this to me however many times I actually want it. So I'm asking for a sensible every 5 seconds, because I don't think that the air quality is going to change within 5 seconds. And I chose 5 seconds because within a talk that's relatively interesting, but for real map tracking and data tracking, I think it'd be more realistic for 10 minutes. Because again, air quality won't change that much between that time if we're dealing with a large catastrophic event like a wildfire. So I'm pulling out the density. You'll see there AQI equals utility.convert. I'm actually running my own little algorithm to convert the particulate density into the AQI value that we all know and fear that we see on the map. And I also get a temperature reading. I just grab that as a freebie. There's an onboard temperature sensor within the Pico W unit. I just decided to grab it as well. I grab all of those, and then I have results equals redis.xadd. And that's actually including all this information to a stream data structure. And I'm including, well, the stream key is just going to be just the name of this key I'm going to be referencing. I'm setting it to sensor::raw. And I'm adding the target, which is the sensor location or the sensor name. So I'll be adding sensor 1 or unit 1 or unit 2, unit 3, and unit 4. I've named these office, bedroom, spare bedroom, kitchen, outside, greenhouse, things like that. Anything where you can actually locate it, and I'd recommend that it be unique. So I add all of those to this stream, and I'm good. And then the countdown timer, I always just drop down every 5 seconds, and then I actually have the unit sleep and everything sleep for 5 seconds. So I can take that reading again in the next 5 seconds. So to talk a little bit about the stream data structure, this is really great for the sensors because once you put this information into a stream, it doesn't go anywhere. So this is great for creating a source of truth that other services can actually consume at their lazy convenience. And a stream, the best way I can describe it within Redis would be a set of dictionaries that is slightly immutable. So I can trim the stream, otherwise we'd have these infinite streams that would destroy the world. No, I want a regular data structure that I can trim, and I can set it by time or by the maximum amount of entries I have. Streams for Redis also automatically set these entry IDs as timestamps. So that's also very important for my particular project because I love timestamps because I'm taking timestamp values along with my readings. So that's just a freebie right there. And you'll notice these little -0s and -1s and -2s at the end of the timestamp. That's actually to keep them in sequence. So in the rare event that I have multiple sensors reporting to Redis at the exact same timestamp, they'll still provide the ability to keep it in order by having those sequences. So if you see that and you're like, what is that? Now you know. So if I can do it with one, I can do it with multiple. In the last 4 months, I've been installing these in every single room, except for the bathroom. And they're great. They're really great. As you can see here, they're running on a power bank. The one over there is running on 3 rechargeable AA batteries. And it'll run for 10, 11 hours. It's really not that bad at all. And then I have this one running on my laptop without really any kind of draw. And I cleared out the entire Goodwill resource of wallboards while building this, so I apologize, Kitsap County Goodwill. So I have this stream full of readings. What can I do with it? Well, everything, if I really wanted to. Time series is the main thing. I love visualization, so I think it's really important to see my data over time, how things have changed, and it actually does give me a lot of interesting information. Alerts. Thanks to today's very interesting presentation, I'll be switching from Twilio to Vonage. So I can send SMS alerts to myself or anybody if they want. Say, hey, the air quality in your kitchen has been really bad. Like, you should reconsider what you're cooking. Or you should check if there's a fire in your spare bedroom if the 3D printer is stuck on a loop. Also, I can convert it to JSON, and I can store averages, max, min, things like that. And then within the JSON, Redis has the query capability, so I can start indexing things, so I can search for values based off a timestamp, location, show me everything where the air quality was bad within the last 2 weeks or something like that. So here I am creating a time series. So I'm going to be reading from the Redis stream this is again at my convenience, so this doesn't have to be real time. It'd be nice, but it doesn't have to be. So the top redis.xread, that's just reading one stream entry at a time, and if it doesn't have anything to read, it'll wait for 50,000 seconds. And then I'm going to pull all that data out of that time entry. So it's going to give me the timestamp. Then I'll be able to get the AQI value, the particulate matter density value, that original value that I pulled from the sensor, as well as the temp. And then here I am at the bottom here. I am creating 3 different time series. A time series is basically just a large collection of a timestamp and a value. We can also add labels like location, or if it's part of a larger subgroup or a larger group, so you can kind of run queries amongst different time series. But for this, I'm just keeping it pretty simple. And I'm creating basically a consistent naming of TS for timestamp, colon, and then my location. So these are creating TS colon unit 1 colon AQI, or TS colon unit 4 colon temp, things like that. It's kind of like the Redis naming convention that we like to use. So I'm creating these 3 time series for every single reading that is read in. So that's going to be a lot of time series, but again, it's quite compact, so I'm not too worried. And the main thing I wanted to do with this project was visualize it. So with Grafana, I connected using a simple JSON plugin, which they'll just send a very easy to read request to a server that you set up. You process that request and you send something back. So here I am going through what they actually want. So when you look at, actually, let me see if I can show you real quick into the future. This is Grafana, and this is today, for all intents and purposes, starting at noon, the air quality. If I highlight a certain section, here's a live demo, let's hope it works. Hey, nice. What I did is I just highlighted a section and said, I want to look at this time frame to this time frame. So I give it a from and a to, and the density or interval of how many readings I want to get. So that was an actual request. So what happens is, I pull out that from time, that to time, and that interval, and I figure out what they're actually wanting to look at. In that case, I believe I was looking at unit 1, so that's this sensor right here. And so I have all the required information to ask for the pieces of info. And here I am up here on the top, calling redis.ts.range. And so I'm saying, hey, look at unit 1, from this timestamp to this timestamp, give me the average of all of those values in an interval. So if I had 500 individual readings every 5 seconds, I can't fit all of that onto my Grafana view. So I'm just going to take the average of every 50 seconds or something like that. And you can do this with more than one actual reading. So if I want to take, say if I had all these 4 sensors distributed across all of this room, I could have them all averaged at the same time, which would be pretty interesting. So again, this is just another view of Grafana. This was my spare bedroom. I believe I was printing one of these boxes and the printing ended gracefully. I shut it off and the air quality went down. It's very interesting because you can see just natural behaviors, human behaviors that you wouldn't think really cause a lot of particulate density, but 3D printing is kind of bad, which I didn't really want to know, but I kind of knew already. Cooking, ooh. Cooking is very bad. But again, that's food particulates. Those are totally fun. That's very easy to breathe in organic matter. What we're actually worried about, what I'm worried about is wood smoke, which is full of toxins, especially if it's wildfire smoke and you can't tell what it's been burning. So it's burning a Tesla, it's burning a house, it's burning a commercial building. So these are all like good examples of what would happen on the inside, but I'm not worried about high values on the inside. I'm more worried about high values coming from the outside. And I'm also actually at my leisure consuming the stream and creating my JSON objects and updating them as well. So here I am pulling out one entry ID. So I'm just going through the stream and reading everything, pulling out my timestamp, my sensor readings, and what target it is, so unit 1, 2, 3, or 4. And then I'm actually just setting the JSON within Redis and just plunking it in. If it exists, it just updates the values. If it doesn't exist, then it creates a new. So that's kind of nice. And then I'm actually keeping, on the bottom there, and that finally, I'm actually keeping a rolling view of what entry I stopped at, so I know where to go next, just so I don't have to restart from the beginning. And I also wanted to do some notifications, just to prove that we can start creating a ruckus if there's some dirty air going on. So what I did is I created an array of 12 integers. So I started off as 0. Why 12? Well, if I'm doing a reading for every 5 seconds for this demonstration project, 12 5-second intervals, that's a minute. So like, well, if the air's nasty for a minute, it might be worth letting somebody know. If it's just some sort of weird, like, quirk, like a neutrino from the star blasted through one of these sensors and said the air quality is 1,000, I'm not going to be worried about that. I'm more worried about if the air quality is 100 or more after a minute straight. So here I am saying if my JSON object doesn't have this array of last 12, then I'll make one. If it does, then I'm going to add the most recent reading and pop out the last reading. So it's going to be a sliding window of my readings. And down here at the bottom section, if the sum of all of those 12 readings is above my threshold, the odds are that it's actually going to be unhealthy. So if I have 12 100 readings, 12 times 100, and that's not healthy. So I want to be known, I want to be notified that something's not good. Also, this is from me learning. I don't want to get spammed with text messages. This will happen as fast as a while loop can happen, and I'll thrash my free Twilio account. And that was really unfortunate, so I had to learn that the hard way. So I created a little stopgap, user notified. So user notified was just a string I set in Redis. Right there, I'm actually on the top saying has been notified, and that's just yes or no. If not has been notified, then notified, and just then set notified to has been notified. And I can set an expiration there, so that 3600, that's an hour of time. So that entry in Redis will exist for an hour, kind of like a session store. And then here, it's just really, really simple code of me contacting with the Twilio little chat agent, or the SMS agent. Hey, your error sucks. You should probably do something, and it's in this location. So I did test that out. It does work, which is really great. So what else can I do with this rather than just send out text notifications or look at pretty charts? You can send it to a Pico server, trigger an electric relay that activates something bigger. So this small signal can activate bigger signals. So HVAC, fans, air purifier, window openers, window shutters, your HVAC system, anything like that. Has anybody ever checked out Purple Air? Purple Air is an open source mapping app, and they actually use the air sensors that are in here in there. So that was kind of my inspiration to do this. You can share that data with a larger community, which gives you just more data. Send notifications to Alexa. You can say, hey, just a reminder, your kitchen is just on fire, you know. A little alerting, but I think her voice will be very soothing when you hear that. Email notifications, things like that. Just, it's not difficult. And most interestingly, I thought, creating a heat map of a building of changing AQI values. So when I cook a delicious dinner in my kitchen, I didn't know this, but the air leaves my kitchen and goes into my solarium, my little sunroom, and it just stays in there a lot longer than it was in the kitchen. Why? I have no idea, but that's interesting. That means there's negative air pressure in my sunroom. That's not interesting to you guys, but it is for me, but so, whatever. So that's basically it. It's something cool that you can do with hardware and MicroPython and Python. That was really cool. You don't have to use Redis. It'd make me so happy if you did. But if you're interested in time series, there's InfluxDB, there's Kinetica, there's a ton of different databases. Redis I like because they pay me, and it does exactly what I needed. So, all this code is up here, so please check it out. The Pico code, those little scripts that I have that create time series and JSON, the API code for accessing Grafana, the STL files for printing the box. I'll also include the actual hardwares with the threaded inserts. You can actually put it all together, and also have some data sources for the statistics. And just to show you what's going on right now, I have really great news. This is the stream of all of these air sensors right now. The air quality index is 0. The particulate matter is 0. So these HVAC registers are working really hard and really well, and that made me really happy. Just to put that in perspective, let me show you. This was my hotel across the way, and I was a clean person. It was just cleaned. But what was really interesting, and I'll be completely honest with you, we're all friends. The Python community is very kind. This is me awake, and this is when I took a nap. I'm not a dirty person, I bet. Who knows? Who knows? But this is really interesting stuff. And again, this is somewhat novelty, but I think it's really cool with the fire. And yeah, hopefully this will help you and inspire you to build some stuff. And yeah, I work for Redis, so check out Redis. If you check out Redis on YouTube, you're going to find my face there as a thumbnail, because I created a lot of videos during the pandemic. And thank you very much for attending. Thank you.